Hello kids! Welcome to our first video lesson on solving and graphing one-step inequalities. Let me tell you, teaching from home is much harder than teaching in the classroom, and I miss seeing your faces. But here we go. I hope you've printed out these notes, and we're going to go through them quickly. This is only one-step inequalities. It'll be a piece of cake. I know you're probably familiar with these symbols: less than, greater than, less than or equal to, greater than or equal to. But notice in this table that you might see some other phrases here that you are not so familiar with, like exceeds, no more than, at most, no less than, or at least. So if we do any word problems, you might see some of these phrases and have to translate them. But getting started, when you are graphing these symbols, less than is always going to be an open circle. Greater than is also an open circle. We'll explain in a moment. Less than or equal to is a closed circle. And greater than or equal to is also a closed circle. So you can tell the difference. If there's no equal sign, then it's an open circle. If there is an equal sign, it's a closed circle. And so what do I mean by that? Here's an example. Let's say we have x is less than 7. Now, I got to give you an important tip here. When you read inequalities, you can read them backwards or forwards. You can read left to right, right to left. Here's the way you want to do it. Read the variable first. Wherever the variable is, start with that and go in that direction. So this is saying x is less than 7. When we graph this, if you were drawing your own number line, make it really simple, put some arrows at the end. The only thing it requires is that you put a little tick mark here to say here is 7. Now, since it's less than, this is going to be an open circle. When you graph, please always graph on the line, not above it. Sometimes people have it floating in space. That's not correct. Less than is always to the left if you read the variable first. Greater than is always to the right. So I'm going to graph on the line, and I'm going to shade in this arrow as well. Here's what this means though. Why are we graphing this? Every single point on this line is a solution. So if I say, oh, 0's over here, and I say, is 0 less than 7? Yes, it is. Just like in our algebra before equations, we can check this. That is true. If I picked a point over here that's not graphed, is 10 less than 7? No, it's not. That's why it's not graphed. Moving on. It doesn't matter what variable you have. Let's say we have m is greater than -3. Draw a simple number line. All you have to write is a -3. But it is a good idea when you're dealing with negatives to put where the 0 would be. Again, this is an open circle, and greater than is always to the right. So shade on the line and fill in the arrow. So just to check, 0, is that greater than -3? Yes, it is. This should be shaded in this direction. Next one, let's say a is less than or equal to 0. So now we have something a little different. Place a 0 on the line. Feel free to stop this video at any time if I'm going too fast, by the way, so you can catch up. Closed circle. Why is this a closed circle? Closed circle means that 0, in this case, is a solution. So if I said 0 is less than or equal to 0, it sure is. It's equal to. So that is a true statement. -1, -2, -3, -5,000, all of those are less than 0. And each of those points is a solution. And one more. How about p is greater than or equal to 100? 100 would make this true. 100 is equal to 100, so that's why it's a closed circle. And greater than, again, is always to the right. By the way, let me point out, inequality, this prefix means not. So all of these things are not equal. They could be greater than and less than and equal, but overall they are not equal. Okay, moving on. Here's the thing that you're going to love about inequalities. You solve them exactly the same way as equations, so we're hardly learning anything new right now. There's one difference that we're going to get to. That's it. One. So let's review what we did for equations. Your goal, I know you're saying this with me at home, to isolate the variable. or to get the variable by itself. To get rid of a term, do the opposite operation. Whatever you do to one side, do to the other. And we like equations and inequalities because we can check our work at the end and know that we're 100% right every time. All right, so what is the one difference? The one very important difference is that when you multiply or divide by a negative number, and I'm going to circle by right here, by a negative number, the direction of the symbol flips. Now, if we were in class, we would do this cool activity to show why, but we don't have the availability or access to do that right now, so just take my word for it. When you multiply or divide by a negative number, the symbol flips. That is the only new thing you're really learning right now, unless you're unfamiliar with some of the graphing. So let's try 6 problems, and that is it. We're adding. We're trying to get x by itself. How do we get rid of adding 3? You tell me your answer out loud. I can hear you all. Subtracting 3, of course. Whatever you do to one side, you do to the other. Really basic. We were not multiplying or dividing by negative. Nothing changes here. X is greater than 7. Now, we always graph these when we solve them as well. So draw a number line. Place the 7. Is this going to be an open circle or a closed circle? I can hear you saying open circle. And greater than is always to the right. Just to check. Now, here's how you can check your graph. You can pick any point here that is a solution. Let's pick 10. You can pick anything that's easy. Plug it into the original inequality. 10 plus 3 is 13. Yep, 13 is greater than 10. That means I know that I graphed in the right direction. Let's move on to the next one. My variable's on the other side of the inequality. We don't like to see this too much, but we got to keep it there. I can't move it around. I'm trying to get rid of subtracting 5. So we're going to do what? That's right. Add 5. Whatever you do to one side, do to the other. Negative 5 plus 5, gone. Keep the y on the right-hand side. I didn't multiply or divide by negative. Nothing to worry about. Keep the symbol facing the same way. And negative 6 plus 5, different sign subtract. Keep the sign of the higher number. That's negative 1. Now, here is where you got to be careful. Remember I said before, way back up here, that you can read inequalities either direction. You always want to read the variable first. So read this one backwards. This one says y is less than or equal to negative 1. So when you graph it, it's going to be a closed circle because it's equal to, but less than, y is less than goes to the left. To check. I can pick anything over here, like negative 3. Should negative 3 be true in this inequality? If I plug it in up at the front, at the original equation, negative 6 is greater than or equal to, substitute in my negative 3, minus 5. Remember we did this with equations. You can check your work all the time. Is negative 6 greater than or equal to negative 8? Yes, it is. So that tells me that I graphed in the correct direction. But be careful. Always read the variable first. Let's move on. Next one, I want to get rid of negative 7. This is one that looks tricky sometimes. Add 7 to both sides. The w is by itself. 10 plus 7 is 17. A quick graph. Is this an open or closed circle? Closed. And w is less than, so graph to the left. All right, no signs have flipped yet. We got 3 more problems. I'm sure we're going to see some flipping coming up. All right, take a look at number 4. Now we got some division that we're going to have to do because this is 5 times x. Show your division as a fraction like we've been doing. The 5's cancel out. Now, am I dividing by a negative? No, I'm not. I'm dividing by a positive 5. Nothing's going to change. It doesn't matter that this is a negative 100, means nothing. The symbol faces the same direction and divide. A negative divided by a positive is negative. To graph it, I ask myself the same questions every time. Is it going to be open or closed circle? It's going to be open. And does it go left or right? X is less than, and less than is to the left. All right. Now, this next one. Here's what you really always want to be looking for. If you ever see a negative coefficient and you know you're going to be multiplying or dividing by a negative, that's when things are going to flip. So I want to get rid of this negative 5 times x by dividing by negative 5. Whatever I do on one side, I do on the other. The negative 5's cancel out. The x stays here on the left. The only thing is the sign flips direction, or one change. And a positive divided by a negative is negative. Now let's just consider this one graph carefully. It's going to be an open circle. And this is saying x is greater than negative 20. So shade to the right. And let's check this. Now, you can always pick any easy number to check your work. So I just picked 0. So if I plug this in, negative 5 times 0 would be 0 when I substitute. Is 0 less than 100? Of course it is. That means my graph is going the right way. Now, what if I hadn't flipped the sign? What if my graph was going the other direction and I decided to check if any number over here would make it true? Well, let's just pick like negative 100. That's easy to plug in. Negative 5 times negative 100. Now I know that this isn't true, but what if I didn't flip my sign is what I'm checking. A negative times a negative is positive, and I would get 500 is less than 100. Obviously not true, which means it should not be shaded this way. So that's kind of a short explanation of why do we flip the sign? Because it makes it true. That is why. And we have one final question. On purpose, I put the variable on the right-hand side again. I'm going to get rid of this negative 5 by dividing by negative 5 again. That's the one thing I want to be really careful of. Keep the x here, flip the sign, and a negative divided by negative is positive. And let's see what this graph looks like. An open circle. And be careful, read this backwards. X is less than 20. You could rewrite it like this. X is less than 20 means the same thing. But make sure your graph comes out right. Less than is to the left, only if you read the variable first. Let's see if it's correct. I'm going to pick 0. That should be a solution when I plug it into the original inequality. Negative 100 is less than negative 5 times 0. Is negative 100 less than 0? Of course it is. That's right. My graph is going the correct direction. All right. Thanks for listening. I know that was quick. I hope you stopped the video if you needed to catch up. Your assignment today is going to be some Mathia. And next time I have a video, next assignment is going to be 2-step inequalities, but there's really nothing new to learn. This is pretty much it. I hope you guys are doing well at home. Miss you.